All right, let's jump right in. Welcome to today's Explainer, where we're looking at a pretty chilling reality in modern supply chain defense. If you spend your days building, sharing, or just searching for open source tools, you probably trust your own eyes, right? You search for a name, see the familiar README formatting, spot the right description, and you just click download. But what happens when what you're looking at is a perfectly constructed mirage? Today, we are dissecting a fascinating digital forensics tool called the Repo Impersonation Monitor and the incredibly sneaky attack vector it was actually built to stop. The creator of this tool shared a highly relatable anecdote in their documentation that kind of kicks this whole thing off. So they were trying to install an open source tool they'd just seen featured in a video. Standard stuff, right? They search GitHub, land on what looks exactly like the right repository. The README and the description, copied almost verbatim. But when they looked a little closer, the actual source directories were completely stripped out. The only thing the repository actually shipped was a single Windows executable. But checking that binary's embedded metadata, and crucially, without ever actually running it, they realized it identified itself as an entirely unrelated quote-unquote licensed product. It was literally a malware thropper wearing the project's name, just writing the traffic that video sent. They caught it. But, the next person searching that exact name, they probably wouldn't. And this brilliantly illustrates a growing threat the industry calls repo confusion. Unlike those super sophisticated hacks that compromise automated build systems, repo confusion relies entirely on social engineering and visual deception. It targets you, the human sitting at the keyboard, typing a query into the GitHub search bar, and simply picking the wrong result from the dropdown. The attacker is totally betting on you moving too fast to notice the subtle discrepancies. Now, there's a really fascinating contrast in how we actually defend against these threats. We have pretty robust defenses and existing tools that guard package registries, think NPM or PyPy, but those defenses are laser-focused on mitigating install time code execution risks, basically stopping the machine from pulling down bad code. But those tools, they are completely useless against repo confusion. Why? Because repo confusion completely bypasses those registry guards by targeting human search behavior instead. So the fastest way these malicious clones actually get taken down isn't through some automated global scanner. It's through a direct takedown report filed by the real project's owner. Section 1. The countermeasure. Enter the Repo Impersonation Monitor. Let's take a look at the tool built specifically to put that takedown lever directly into the maintainer's hand. Think of the Repo Impersonation Monitor as an automated digital watchtower. It's essentially a scheduled GitHub action that you drop right into your own repository. On whatever schedule you set, it acts as a scout, actively searching GitHub for repositories that are trying to impersonate yours. It's looking for name collisions, vanity organization clones, and those near-verbatim README copies we talked about. And when it finds a high-confidence match, it doesn't just ping you. It literally hands you an evidence-ready abuse report, pasted right into an issue in your repo, totally ready for you to submit to GitHub Trust and Safety. Maintainers configure this action using a few really simple inputs. You give it the project name, the exact string an impersonator is going to try to copy. You can also throw in an allow list to tell the monitor to ignore known good copies, like legitimate mirrors or translations. But the feature I absolutely have to highlight here is dry run. I highly recommend using this first unless you like accidentally spamming your own repo with false alarms. Setting it to true lets the monitor safely log its findings without actually opening any issues or needing write access. It is the perfect way to see exactly what would be reported before you fully unleash it into your workflow. Section 2. Anatomy of a fake, focusing on spotting structural tells. Let's head over to the evidence board and see exactly how this tool spots the fakes. The monitor weighs several red flags, focusing heavily on durable signals that are really hard for an attacker to fake. First off, obviously, the owner isn't you. Second, and this is a massive red flag, the repository is not a fork. Attackers deliberately avoid using GitHub's standard fork button because they desperately want to dodge that attribution link back to the original project. Third, the clone was created super recently compared to the real established project. And fourth, it ships a compiled binary release that the real project simply doesn't even offer. Now, the crucial point is really how all these signals combine. The monitor zeroes in on the strongest combined tell of an impersonation attempt, which is a perfectly copied README and description sitting right on top of a completely empty or stripped out source tree. To a user just glancing at the landing page, everything looks familiar, everything looks right. But underneath that documentation, the actual code is totally missing, replaced by a malicious payload. The monitor also hunts for what's called a PE version resource mismatch.
Basically, it looks for platform and path inconsistencies. For example, if you maintain a macOS command line tool, but this clone's only artifact is a Windows installer, that's a pretty big problem. Furthermore, it parses the embedded metadata within not binary. A lot of the time, attackers are just lazy, and the executable's product name or company name metadata will name an entirely unrelated, supposedly licensed product. That exposes the lie instantly.
Now, falsely accusing a legitimate mirror, fork, or translation is a real harm to the open source community. So to prevent that, the tool uses strictly conservative confidence tiers, scoring findings from low to high. By default, the monitor will only automatically open an issue if the score reaches the high tier. And honestly, reaching high is tough. It requires a minimum score of 0.60, at least 3 strong signals, and importantly, at least 1 core structural tell, like that stripped source tree or the PE resource mismatch we just went over. No single signal is ever going to trigger a high confidence alert on its own.
Moving into Section 3, the tool's core philosophy, which is to propose, never accuse. Let's pivot and examine the strict design constraints behind why this tool was built this way.
The creator built this thing with extreme caution. By design, it is strictly opt-in. There is absolutely no global crawl of GitHub. It only protects projects whose maintainers actively install the action. While this does structurally underserve new or low-visibility projects, avoiding a hosted Watch Any Project service was a deliberate choice to keep the scope manageable and, most importantly, safe. Second, it proposes an issue but never accuses independently. It puts the evidence right in front of a human, but you always make the final call on whether to file that takedown. And finally, it never actually executes suspected malware. It strictly parses metadata using libraries to read the binaries headers safely. This philosophical approach acknowledges a really hard truth in cybersecurity. Detection heuristics have a half-life. Attackers aren't static. They will inevitably adapt. They're going to start regenerating README slightly differently or cycling dummy commits just to dodge automated time-based checks. And that is exactly why this monitor leans so heavily on those difficult-to-fake, durable structural signals. But as the documentation wisely notes, static rule sets are just a mitigation. They are not a cure. The Repo Impersonation Monitor gives us such a fascinating look into the modern realities of supply chain defense. We spend so much time securing our code, our pipelines, and our registries, but the attackers, they're simply walking right through the front door, wearing our name tags and greeting our users. It leaves us with a critical thought to end this explainer on. In this ongoing open source arms race, how many developers are downloading perfect replicas of your work right now? And isn't it time you checked? Thanks so much for joining me for this explainer, and stay secure out there.